We're now going to look at container technology. This is one of the advantages of virtualized systems or virtualization, and not just in the cloud, but in any sort of system. And so we've got virtualization and we've looked at that with virtual machines. And now we're going to look at containers and how they work, and we're going to compare them against virtual machines. So what are containers? With a container, you have an executable unit of software, and what that means is that you have application code and it's packaged along with all the libraries and dependencies that it needs so it can run anywhere. So in other words, it's taking a little part of the operating system with it, just enough to do what it wants, so to run this application. So containers are a form of OS virtualization, but not like a virtual machine where what it does is leverage everything. It's taking the whole operating system and virtualizing it. With this, we're going to isolate processes and the amount of memory and disk and everything else that they need and package that up, and that's what we're going to call a container. So a container will allow an application to run quickly and reliably between computing environments. So in other words, you can take a container and you can put it in one computing environment and run it. And then you could take that same container, put it in another computing environment and run that. And it would react the same way. And so it looks like it's just an application running, and you don't really have an idea of what it's running on or where it's running. So the container is isolating the software from its environment. And in that way, it's not dependent on its environment. So you have this uniformity over multiple environments. And you have this problem all the time when you change environments, that some things work slightly differently. And so you have all this problem with having software that you want to put in different environments, and then having to either in the software itself read what's in the environment and take steps to make it run in there, or you can containerize it and then you're isolating it from the environment, so you don't have to care what's in the environment as much. So containers and virtual machines are doing similar things in that they want to take resources and isolate them and allocate them to particular applications. But they're different because containers virtualize the operating system, whereas a VM is virtualizing the hardware. And so containers, therefore, are more portable and efficient because they're much smaller. So they're faster, they're far more portable because they're doing fewer things. So they're really working at the operating system level instead of worrying about the hardware, which the virtual machine has to. Now, the way we get containers comes a lot from how Linux handles containers. So the cloud didn't invent containers. Containers were there for a long time because there's features in the Linux kernel that can be used to create containers. And so there were Linux containers before there was the cloud. Really what we're looking at is yet another form of virtualization. With Linux, the Linux kernel has three things that allow it to be used for containers, because it does this resource utilization and abstraction of processes. So you have three different things that help with this: control groups, namespace isolation, and the union file system. And I want to look at the first two in detail, because just to give you an idea of how containers work, because once you get into using containers, a lot of times you forget just what you need to create a container. And there's lots of reason why you might want to create your own container. So you don't want to just be a user of containers. You also want to be able to containerize your application. So first, let's look at control groups. Control groups, or C groups as they're known, are a Linux kernel feature. And what they do is they organize processes into hierarchical groups. And this is done for usage of various types of resources. And so what you want to do is, in an operating system, you often want to limit the amount of resources any process or application can have, because you don't want one taking up all the resources, because it become very inefficient. And you also want to be able to monitor what's happening to the resources. And so this grouping that control groups allows you is implemented in what's called the C group kernel code in the core of the kernel. And the resource tracking and limits are implemented in various different types of subsystems, because it depends on what resource you want to track and maybe limit. So things like memory or CPU. Those systems will have the ability for you to do resource tracking and limits, and put limits on the resources. So C group is a collection of processes that are bound to a set of limits or parameters that are defined via this C group file system. So we all know a file system is hierarchical, so we use the notion of a file system to capture this notion of a C group. So a subsystem is a kernel component that modifies the behavior of the processes in a C group. And various subsystems make it possible to do things where you want to limit some sort of resource, like CPU or memory or anything like that, or assign accounting to a particular group, or freeze execution of processes, or resume execution of processes. And so these subsystems are controllers. So they control resources. And that's what you need when you want to have many different isolated systems or containers that are doing things. So you have to have the ability to organize it and limit what it's using in the resources, and giving it access, obviously, to the resources. So the groups for a controller are arranged in a hierarchy, and you do this because it's designed like it's an operating system. And so you create, remove, rename subdirectories within this C group file system. So at each level of the hierarchy, various limits can be defined. So you can have limits, control, accounting, everything like that on these C groups, and everything underneath that group in the sub-hierarchy has its attributes defined by what's above it. So one of the design goals for C groups, why they put that in there, was that they wanted to have this unified interface for different use cases. So, and this goes all the way from controlling single processes in the operating system to full operating system level virtualization. And obviously with that, you now can have a container, because you're virtualizing at the operating system level. So in summary, what are the features of a control group? So they can be used for resource limiting, so you can set something so that they won't exceed certain limits. You can prioritize some groups so they get larger shares and first shares of certain resources. You can do accounting, so you can measure what a group is doing. And you can do control, so you can freeze processes, you can checkpoint them, you can restart them. So all of these are features that the operating system needs, and that you can take advantage when you want to containerize an application. Now, the next concept is namespaces. And I think probably everybody is familiar with this concept, in that with a namespace, you're wrapping anything, in this case, we're looking at a system resource, in an abstraction. And it makes it appear to anything within this system, that within this namespace, that they have their own isolated instance of this resource. So in other words, they're in their own little world. So namespaces define little worlds. So it looks like, this is your part of the global resources. You see that, it's your world. Changes to the global resource are visible to processes that are members of the namespace, but they're invisible to other processes. So in other words, we're doing this separation. Namespaces separate. So anything that's outside the namespace can't see what's in the namespace. Anything within the namespace can see everything. So one of the uses that namespaces have been put to is to implement containers, because obviously a container has to have its own little world and has to be separate from everything else. So what are the advantages of virtual machine? So virtual machines are an abstraction over the physical hardware. So it's really taking a server and putting it and making it look like it's multiple servers. So a hypervisor, that piece of software that you have to create virtual machines, it allows multiple VMs to run on a single machine. So each VM includes a full copy of an operating system, the application, all the binaries, libraries. These can be huge. And so starting up a virtual machine, and I'm sure everybody that has started to instantiate VMs on either AWS or Azure has seen it takes time. It's not instantaneous. So it's not that you can do this really quickly, because it's just like booting up your machine. These are large pieces of software and it's handling everything. And so virtual machines are large, but they give you everything. You have your own little machine. How about if we compare VMs to containers? Well, as we've seen, VMs are a heavyweight solution because they're doing everything. They're not just giving you an operating system, they're giving you all the physical architecture underneath that. You're getting a virtualization of that. Containers, on the other hand, are very lightweight because they're doing it at the operating system level. And in fact, they're not even taking the whole operating system. Most containers don't need the whole operating system. So they're just taking the part that they need. With a virtual machine, it's fully isolated. This is its own little world. The only thing it's actually mapping to is the actual hardware, but multiple VMs on one machine, they don't know about each other. It's fairly secure. They're not going to interfere with each other. Now, with containers, a little bit different. They're at the process level for isolation. So while they do have their own namespaces and they do have their own set of resource limits, they're not as guaranteed to be as secure as a VM is. So, you give up some security where somebody might be able to break the isolation, because you have two sets of isolation to look at, because you have the isolation between the container and the actual host operating system that it's running on, and the container and other containers within that system. With virtual machines, obviously very slow to deploy because it takes time. It's a big chunk of software that you have to do. Whereas with containers, very rapid. Like I said, they can be very small. And in fact, you're going to see when you start looking at what we're going to look at, which is Docker, you can see that you can actually make some of these containers very, very small. With a virtual machine, it's pretty easy to do IP addresses, port mappings, all of those things, because you're getting really close to this physical mapping. So the virtual machine is trying to make you feel like you're the only thing that's running on the hardware. Whereas with a container, it's more abstract. Because it's at a different level, process level, there's more abstraction for the IP addresses and port mapping, which makes it a little bit harder to manage. It's just a little bit more abstract, and so you have to do a few more things. It's a lot easier on a virtual machine. With a virtual machine, too, you need custom images. So they're not portable across cloud platforms. And in fact, if you actually look at the different images that you have, even within a cloud platform, you'll see that within, let's say, AWS, for example, if you go between regions, they don't have all the same images. Some of that may be because of certain commercial things, but it also is that they're not running the same hardware. And so you have to have custom images to run, for the hypervisor to run. Now, with containers, they're completely portable. And so you have far more versatility with containers. You're able to deploy everywhere with a container. It's very lightweight that way. So if we look at this diagram, what we're going to see is that if we look at on the right-hand side, this is what an architecture looks like with virtual machines. So you have the infrastructure, the hardware at the lowest level. You then have a hypervisor. And then on top of that, you have the virtual machine. They have their own operating systems. The hypervisor is running within, or either is sort of like an operating system, or it's running within the host operating system, whereas virtual machines have their own guest operating systems, and they're running different applications on them. And they're completely separate from each other. And when you instantiate a VM on something like AWS or Azure or Google, whatever, you don't know how many other virtual machines are on that actual physical hardware. In fact, that's one of the choices that you may make for money. You can tell them you want to be on certain hardware and maybe you only want your virtual machines there. You have to pay for that privilege. But if you don't, you have no idea how many you don't even know the number of virtual machines that are running on the actual hardware. If we look on the left-hand side at what happens with containers, you have the hardware, then you have a host operating system, and then you have some form of a containerization system. In this example, it's Docker. It's one of the most popular right now. And under Docker, it can run all sorts of different applications. And so you have the host operating system, and then you have all these applications. And those applications didn't actually have to be developed on that host operating system. They take the pieces of the operating system that they were developed on and need with them, and they're run within their own system within Docker, and it can run these containers for you. So it's a very different setup, and it's very lightweight to put these actual containers on the system. But you can see that it's really Docker is running on the host operating system. And so you have this interaction with the host operating system. And so there's not complete isolation between the containers and the host or the containers themselves. So what are the advantages of containers? Well, they're an abstraction at the application level, at the operating system level, packages up the code and dependencies together. You can have multiple containers running on the same machine. They can share the OS with other containers. They can each run isolated processes in user space. You have many of them. They are sharing all of the resources there, but to themselves, they look like they're in their own little worlds because they're within their own namespace. Containers take up less space than VMs, obviously. They're not packaging up everything about an operating system. They can handle lots of different applications, and you don't really need as many VMs or operating systems when you're trying to deploy everything, because you're actually packaging up everything you need in the container. And so what you really can do is just set up VMs that run containers, and you can run many containers within that one VM. You don't have to set up multiple VMs. So there's got to be some disadvantages, as this cat is finding out, of container technology. So what are the disadvantages? Well, as we've seen, there are security issues. They're running on a host operating system. You're not completely isolated from it, like any application that's running on a host operating system. So obviously there may be security issues that you're not going to run into as if you're running VMs. Managing the network and IPs and all that, different things, ports and all that, can be much more confusing, much more difficult, because it's abstracted. And so you're not doing this direct mapping like a VM is doing with the hardware. And the other thing is efficiency. If you're really looking at it, if you think when you're running in the cloud, you maybe have lots of containers or on top of VMs, which are on servers, which are running multiple VMs. And so, and you don't know the configuration that you're running on. You don't know how many you don't know how many VMs are on your server. You don't know what they're running. But containers give you, while they may not be the most efficient, but you can gain efficiency because you can make them extremely lightweight. And there's lots of different things that people have done to make very lightweight parts of very lightweight actually operating systems that will be containerized, so that you're taking very little with you in the container. And so you're going to see that when you start working with something like Docker and making your own containers or running other people's, you can have choices about how big they are, and therefore how many you can run, how efficient they are. So this is understand how the container works, and now you can take advantage of the fact that containers can allow you to get out there and to put your application into many different environments without actually having to change your application. So there's other material in this learning module on using Docker and examples of using Docker. So what I would suggest is after you go through this, go start, install Docker, and start working with that. Maybe get onto Docker Hub so you can look at all the different containers that are out there and start playing around with them.